When we think of the word genius, our minds often gravitate toward figures like Einstein or Newton, despite the remarkable brilliance of other intellectual giants such as Gauss or von Neumann. But why is this the case? To unravel this, we must delve into the profound impact of paradigm shifts in science, a concept famously discussed by Thomas Kuhn. Thomas Kuhn, in his seminal work The Structure of Scientific Revolutions, argues that science doesn't progress in a steady, linear fashion. Instead, it undergoes revolutionary changes, known as paradigm shifts. A paradigm is more than just a theory. It encompasses the entire worldview, problem-solving methods, and fundamental assumptions accepted by the scientific community at a given time. Before Newton's time, Aristotle's physics dominated. This worldview, grounded in everyday experience, posited that objects inherently seek to rest, requiring continuous force to maintain motion. Additionally, it held that the universe was geocentric, and celestial bodies moved in perfect circles. Newton's arrival heralded a radical new paradigm. His classical mechanics introduced a completely different way of explaining natural phenomena. Newton's first law, the law of inertia, stated that an object remains in its state of motion unless acted upon by an external force. Furthermore, his law of universal gravitation explained the movement of celestial bodies using mathematical principles, thus discarding Aristotle's intuitive but flawed concepts. Newton's theories introduced a deterministic worldview, laying the foundation for a mechanical understanding of the universe. This revolutionary paradigm provided scientists with a new lens through which to view the world, and it dominated scientific thought for centuries. It's this profound shift in scientific thinking that makes Newton synonymous with the term genius. He didn't just make discoveries, he fundamentally altered the language and framework of science itself. Newton's paradigm reigned for hundreds of years until the 20th century, when scientists began to recognize its limitations, particularly at the extremes of scale, cosmic and atomic. Enter Einstein. His theory of special relativity and general relativity proposed a new paradigm that surpassed Newton's. Einstein's special relativity challenged the notion of absolute time and space, asserting instead that they are relative. His iconic equation, E equals mc squared, suggested a revolutionary idea that mass and energy are interchangeable. Further, Einstein's general relativity redefined gravity not as a force but as a curvature of spacetime. This theory replaced Newton's law of universal gravitation with a more fundamental understanding that underpins modern cosmology, enabling concepts like black holes and the Big Bang theory. From Kuhn's perspective, Einstein and Newton were not merely exceptional scientists. They were architects of new scientific frameworks that reshaped the very foundation of science. Their discoveries addressed problems that the existing paradigms couldn't solve, guiding science in new directions. This is why they are often perceived as geniuses. On the other hand, figures like Gauss or von Neumann, while immensely accomplished, operated largely within existing paradigms. Their contributions, though groundbreaking, didn't overturn or radically redefine the scientific frameworks of their time. Thus, when the word genius springs to mind, we think of Einstein or Newton not just for their formidable intellect but because they restructured the entire landscape of science. Their influence transcends mere discovery. They reoriented the trajectory of scientific history itself.
The first rule of channel is subscribe channel. Second rule of channel is click like. This channel will make you smart.